In this video, we're going to be factoring trinomials with a leading coefficient greater than 1. And the way we're going to do this is by factoring by grouping. So if you haven't already watched the video on factoring by grouping, I'm going to go ahead and put the link down below in the description, and that way you can go ahead and click it and watch it first. So if you've already watched it, then you can go ahead and keep up with what we're doing today. So if you take a look on the left-hand side, 3x squared plus 11x plus 6, then notice that we have a trinomial. There are three terms. The first thing you always try to do when you are factoring is look for a greatest common factor. That means you want to ask yourself two questions. Are all of these numbers, the 3, the 11, and the 6, divisible by the same number? And you also want to ask if all of the terms have the same variable. In this case, the first term, 3x squared, has x squared. The second term has an x, but the 6 does not have an x. So right now, they do not have a GCF, which means that I'm going to go ahead and try to factor this without finding a GCF. This is a trinomial, as I've already told you, which means that it has three terms. The leading coefficient is not 1. Therefore, I'm going to show you how to use factoring by grouping to be able to factor. So the first thing we're going to do is take the first number, 3, and multiply it times 6. 3 times 6 in this case is positive 18. Now you want to ask yourself, what multiplies to give me positive 18 that's going to add to give me positive 11? Okay? So what multiplies to give me positive 18 that's going to add to give me positive 11? So 18 is 3 times 6. That's not going to add to give me 11. 2 times 9. 2 times 9 is going to multiply to give me 18, and it's going to add to give me 11. So what I do now is that I'm going to rewrite the problem. I'm going to write 3x squared plus 2x plus 9x plus 6. So what I really have done is taken this middle term, 11x, and I've broken it up into 2x and 9x, because if I combine like terms, I get back 11x. By doing this, I'm allowed to now factor by grouping. So I'm going to group the first two together, the last two together. From the first two terms, I have an x in common, so I factor it out, and I'm left with 3x plus 2. From the second group, they are both divisible by 3, so I bring down the plus, and then I factor out the 3, and I'm left with 3x plus 2. So then what they have in common is 3x plus 2, and then I multiply it by x plus 3. So the answer is 3x plus 2 times x plus 3. And the way I've done it in every single video on factoring so far is that we're going to check this by distributing. So if I multiply 3x times x, I get 3x squared. 3x times 3 is 9x. 2x, basically in this case, if I multiply 2 times x, and then finally plus 6, and that gives me 3x squared plus 11x plus 6. So I'm exactly back to the beginning of the problem. Let's go ahead and try the one on the right hand side. So we're going to do the same process. This is a trinomial. We look really quickly to see if we have a GCF, and we don't, because not everything is divisible by the same number. We have 8, 22, and 5. And then not everything has an x. So I'm going to go ahead and continue factoring the way I showed you earlier. We're going to take the first number and the last number, and we're going to multiply that together, and that's going to give me 40. Then you have to ask yourself, what multiplies to give you 40, positive 40, that's going to add to give you negative 22? So if it has to multiply to give me positive 40, the signs have to be the same. And because it has to add to give me negative 22, I know the two numbers have to be negative. So what multiplies to give me 40 that's going to add to give me 22? You got to think about that. 40 is 1 times 40. That does not add up to 22. It's also going to be 2 times 20. So 2 times 20 it's going to be negative 2 times negative 20, because it's going to have to add to negative 22. So negative 2 times negative 20 multiplies to give me positive 40, and it's going to add to give me negative 22. So now I am ready to rewrite the problem. I'm going to write 8x squared, and then I'm going to take negative 2x, negative 20x, which is what I figured, is going to multiply to give me positive 40 and add to give me negative 22, and then bring down the plus 5. So once again, I've broken up the negative 22 into negative 2 and negative 20. So now we're going to go ahead and factor by grouping. I grouped the first two and the last two. Remember that when you have a minus, you want to make sure you include it inside the group. So from the first group, they are both divisible by 2 and they both have an x in common, which means I'm left with 4x minus 1. From the second group, they are both divisible by 5. Because the 20 is negative, I'm going to factor out a negative 5. In that case, negative 20x divided by negative 5 is positive 4x, and positive 5 divided by negative 5 is negative 1. So once I see this, I'm thrilled because that means I'm close to getting the final answer. In this case, I factor out the 4x minus 1, and I'm left with 2x minus 5, and then that's my final answer. Some teachers teach this a little bit differently. Some of them use trial and error, meaning you open parentheses and you kind of play with it to see what will work. And that's fine if you're good at it. I have some students who are actually really good at trial and error, and they can basically come up with the answer pretty quickly by doing it that way. But other students need more structure. And so if you're one of those that need more structure, then this is a step-by-step process that you can use so that you can go ahead and factor trinomials when the leading coefficient is greater than 1. Let's try some more problems. Directions. Factor each trinomial. If it cannot be factored, write prime. So starting with number 1, again, really quickly scan the problem for a GCF. They're not all divisible by the same number. They all don't have the same variable in common. So what I'm going to do is go ahead and start by multiplying the 2 times negative 7. This multiplies to give me negative 14. The fact that that multiplied to give me a negative 14 tells me that I'm going to have opposite signs. So what multiplies to give me negative 14? That's going to add to give me positive 13. So in this case, positive 14 times negative 1 is going to multiply to give me negative 14, and it's going to add to give me positive 13. So once I found what works, I'm going to rewrite the problem. 2x squared plus 14x minus 1x minus 7. Go ahead and group the first two together and the last two together, including the minus. Then from the first group, the GCF is 2x. They both are divisible by 2x. And now I have x plus 7. From the second group, they're both divisible by negative 1. And I'm left with x plus 7. And it's very important for you to take out that negative 1. So now they both have x plus 7 in common. And I'm left with 2x minus 1. And then I am done. You can always check to see if you did this correctly, because if you distribute, if you FOIL, if you multiply it out, whichever way you learned it, then you're going to get back exactly the same problem that you started with. Let's go on to question number 2. Quickly scan the problem. Do we have a GCF? No, we don't. They're not all divisible by the same number, and they don't all have the same variable in common. So let's go ahead and multiply. 2 times 25 is 50. It's positive 50, so I have to have the same sign. What's going to multiply to 50 to give me 50 so that I end up with 27, positive 27 when I add? You might be thinking 25 times 2, and you are correct. 25 times 2 is 50, and it's going to add to give me 27. Let's say you're like, how are you doing that so fast? How are you getting 25 times 2? Well, number one, you need to know your times tables. If you don't know your times tables, that's something that you need to learn because it's going to really help you in math. The second thing is you kind of want to go through the possibilities. So what multiplies to give me 50? 1 times 50. 2 times 25. You have to see, is 50 divisible by 3? No. Is 50 divisible by 4? No. Is 50 divisible by 5? Yes. 5 times 10. Is 50 divisible by 6? 7, 8, 9? No. So basically that's it. These are the only possible combinations. And then from this combination, which one works? 2 and 25, because 2 times 25 is going to multiply to give me 50, and it's going to add to give me 27. So just in case you were like, how is she getting this? I'm showing you right now. These are all the possibilities, and you choose the one that works. So now back to the problem. Now that I notice it's 25 times 2, and it doesn't even matter if you do 2 and then 25, the answer is still going to come out to be the same. I'm going to rewrite the problem. 2y squared plus 25y plus 2y plus 25. I grouped the first two together and the last two together. From the first two right now, they have a y in common. I'm left with 2y plus 25. From the last two, they have nothing in common, so I factor out a 1, and I'm left with 2y plus 25. So now they both have 2y plus 25 in common, and I factor out the y plus 1. And that's it. You're done with the problem. Go ahead and see if you can do number 3 by yourself. Pause the video and then press play. So in number 3, scan it really fast, no GCF. Take the 2, multiply to the 15, you get 30. What multiplies to give me 30? That's going to add to give me 13. 10 times 3. Rewrite the problem. 2x squared plus 10x plus 3x plus 15. Group the first two. Group the last two. So then GCF is 2x. You're left with x plus 5 plus 3 times x plus 5. And now it's x plus 5 times 2x plus 3. And that's it. That's my final answer. Hopefully you got it right. And if you did, high five. I'm so proud of you, because a lot of people struggle with factoring trinomials when the leading coefficient is not 1. So way to go if you got it correct. If you didn't get it right, it's okay because you're practicing. So for question number 4, we have 8y squared minus 17y plus 9. They don't have a GCF, I can tell right away. So 8 times 9 is positive 72. What multiplies to give me positive 72 when I multiply? And then it's going to add to give me negative 17. Negative 8 times negative 9. So let's go ahead now and rewrite the problem. 8y squared minus 8y minus 9y plus 9. Group the first two together, group the last two together, including the minus. From the first group, 8y is the GCF, the greatest common factor. I'm left with y minus 1. From the second group, negative 9 is the greatest common factor, and I'm left with y minus 1. So now I factor out y minus 1, and I'm left with 8y minus 9, and voila, there goes my final answer. In number 5, we have 20r squared plus 27r minus 8. Notice that there is no GCF because the 20, the 27, and the 8 are not all divisible by the same number, and they obviously don't all have an r, which means that I have to go ahead and continue. I multiply the 20 times the negative 8, and then that's going to give me negative 160. The fact that it's negative tells me that I have to find opposite signs. So here you have to think a little bit, because 160 is a pretty big number. 160 is 1 times 160, 2 times 80. It's not 3 times anything. 4 times 40, 5 times 32, and already I can tell that's going to be the value that I'm looking for, because I know that 32 minus 5 is going to give me 27. So it has to be a positive 32 and a negative 5. Again, I'm trying to get a positive 27 out of this combination. 32 times negative 5 is going to give me negative 160, but it is going to add to give me a positive 27. So once I found the combination, I'm going to rewrite the problem. 20r squared plus 32r minus 5r minus 8. Group the first two together and the last two together, including the minus. 20r squared plus 32r, they are both divisible by 4, which would give me 5 and 8. So I'm going to take out 4r, and I'm left with 5r plus 8. Then they're both divisible by negative 1. So go ahead and factor out a negative 1. and I'm left with 5r plus 8. I always get so excited when I see what's in parentheses match, because then you're like, yes, so we're in the right track. So 5r plus 8, factor it out, they have that in common, and you're left with 4r minus 1. So that's my final answer. In question number 6, again, they're not all divisible by the same number. Take the 4, multiply it by 25, and you get a positive 100. So because it is a positive 100, I'm looking for like signs. And in this case, it's got to add to give me negative 20, so they both have to be negative. So what multiplies to give me 100, and it's going to add to give me negative 20. And the answer is negative 10 times negative 10. Negative 10 times negative 10 is positive 100, and it's going to add to give me negative 20. So I rewrite the problem. 4y squared minus 10y minus 10y plus 25. Group the first two together, group the last two together. From the first two, the GCF, they're both divisible by 2y. So we're left with 2y minus 5. From the second group, they're both divisible by 5. So I'm going to divide by negative 5. And that's going to give me positive 2y minus 5. Remember again, negative 10y divided by negative 5 is positive 2y. And positive 25 divided by negative 5 is negative 5. So now I have 2y minus 5 in common, and I'm left with 2y minus 5. This is actually pretty neat because it's the same exact thing, and I can rewrite this as 2y minus 5 squared. In question number 7, when I ask you if there is a GCF, finally we get a problem where the answer is yes, we do have a GCF. Here, all terms have an a. So I'm going to first start by factoring out the a, and I'm going to be left with 8a squared plus 14a plus 3. So now the a is going to hang out there for a while, okay, until we end up bringing it down with our final answer. We are going to focus on the trinomial that's inside of the parentheses. So once again, I'm going to multiply the 8 times the 3, and that's going to give me positive 24. What multiplies to give me positive 24 that's going to add to give me 14? And the answer is going to be, well, let's think. 24 is 3 times 8, that adds up to 11. 4 times 6, that adds up to 10. So it's going to be 2 times 12. 2 times 12 is going to multiply to give me 24 and add to give me 14. So right now, I'm going to concentrate on the trinomial in the parentheses. The a is going to hang out outside until I get ready to bring it down at the end. So I'm going to rewrite the problem as 8a squared plus 2a plus 12a plus 3. Group the first two, group the last two. From the first group, the GCF is 2a, so I'm left with 4a plus 1. From the second group, they're both divisible by 3, so I'm left with 4a plus 1. So here the GCF is 4a plus 1 times 2a plus 3, and then we can't forget to bring down the a that we originally took out, because without that a, we're never going to get back to the original problem. So there you have it. This is going to be your final answer. Let's take a look at question number 8. In question number 8, I don't have a GCF in the very beginning, so I'm going to multiply positive 6 times negative 10, which is negative 60. I'm looking for opposite signs, so something that's going to multiply to give me negative 60, and it's going to add to give me negative 11, which really means it's going to subtract. So positive 60, 10 times 6, but the difference is 4. 15 times 4. So here it's going to have to be negative 15 times a positive 4. Negative 15 times 4 is negative 60, and when you add, it's going to give me negative 11. So take the time right now, rewrite the problem. 6x squared minus 15x plus 4x minus 10. Group the first two together, group the last two together. From the first two, the GCF, they're both divisible by 3 and x. So I'm left with 2x minus 5. From the second group, they're both divisible by 2. So I'm left with 2x minus 5. And again, I get super excited when I see them match. So 2x minus 5 times 3x plus 2. And there you go. That's my final answer. Okay, down to our last two final problems. In number 9, clearly all of these are divisible by 2. So I do have a GCF from the very beginning that I want to go ahead and get rid of. So I divide everything by 2, and I'm left with n squared minus 14n plus 49. And now, wow, I actually have a trinomial where the leading coefficient is 1. So I don't even have to go through all the trouble of what it is that I'm showing you here by factoring by grouping. So instead, I'm just looking for what multiplies to give me positive 49 that's going to add to give me negative 14. Because of this last plus, they have to have like signs, and because of the minus, they both have to be negative. So the 2, remember, is going to hang out there for a little while. Let's concentrate on n squared minus 14n plus 49. So what multiplies to give me positive 49 that's going to add to give me negative 14? Negative 7 and negative 7. So this becomes n minus 7 times n minus 7. The 2, can't forget about it. We have to bring it down. And then finally, I can rewrite this as n minus 7 squared. Take a look at question number 10. Now it's getting even more interesting. We have 10x squared minus 13xy minus 3y squared. Don't get scared because you have that y squared at the end. If you want, even forget about it for now, and let's just concentrate on everything else. So let's kind of pretend the y squared isn't there. So that means let's take the 10, let's multiply it to the negative 3 to get negative 30. What multiplies to give me negative 30 that's going to add to give me negative 13. Be very careful because you might be thinking negative 10 and 3. But negative 10 times positive 3, yes, is going to give me negative 30, but that's going to add to give me negative 7. And that's not what I want. I want it to add to negative 13, so be very careful. You can't just say negative 10 and negative 3 because then that's going to multiply to give me a positive 30. So right now, the 10 and the 3 is not going to work. What else multiplies to give me negative 30? Negative 15 times a positive 2. Yes, this time around, it's going to multiply to give me negative 30, and it's going to add to give me negative 13. So I found the combinations. So we're going to go ahead and rewrite this, okay? When we rewrite this, I'm going to write 10x squared minus 15xy, because remember, this really is xy. Even though we're pretending the y squared is not there, it really is, okay? And then we're going to put plus 2xy, and then I'm going to bring down the minus 3y squared. So no worries, no problems so far, so good. So now I'm going to have 10x squared minus 15xy that I'm going to group together, and I'm going to group these together. So I have 10x squared minus 15xy. They're both divisible by 5, and they both have an x in common. I'm left with 2x minus 3y. In the second one, they both have a y in common, so I take it out, and I'm left with 2x minus 3y. Now they both have a 2x minus 3y in common times 5x plus y. And here we go. Here is our final answer. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.